So for problem number 3, we have a wheel, okay, and the wheel rotates on a surface without slipping. Oops, wrong wheel. Let's get rid of that wheel. What did I do? Hit duplicate? Oh, I meant to delete it. All right. So we have this wheel here, and it's on a horizontal surface, and it says it rolls 5 revolutions. Okay? My wheel rolls 5 revolutions. And it does so without slipping. And if the center of the wheel moves 3.2 meters, so it moves from here to here, and from here to here, the center of the wheel moves a total of 3.2 meters. What's the radius of the wheel? Okay? Do you have a question?
I'm just saying if we just divide 3.2 by 5, we should be able to determine how far it goes in a single rotation.
That's one way to do it. Yeah. So so that's one approach. But what he's saying is that if 5 revolutions is equal to 3.2 meters, then 1 revolution is equal to 3.2 divided by 5. That's one way to do it. And in fact, I had a different way, but let's do it your way. You'll get the same answer either way. So what he's saying is, we have 5 revolutions per 3.2 meters. Okay? Now, I could write that another way. That's the same as saying 3.2 meters per 5 revolutions, right? And basically what we're saying is 5 revolutions is equal to 3.2 meters. So if we do it this way, I could reduce it by dividing the top number and bottom number by 5. So if I pull in my calculator and I say, all right, oops, let me get rid of some of this stuff. So if I say 3.2, whoops, wrong screen. If I say 3.2 divided by 5, I get 0.64. What does that mean? Well, that means 0.64 meters is how far it moves in 1 revolution. So we're asked to find the radius. So we've got to figure out the relationship between the radius and this information. So the one thing that I know is that as the wheel rotates, we're looking at S. Well, the relationship between the arc length S is radius times theta in radians. Well, let's think of what 1 revolution is in radians. What is 1 revolution in radians? 2 pi. Okay, so what we're saying in 1 revolution, which is actually 2 pi, in other words, if I say 2 pi up here in radians, divided, isn't that equal to 1 revolution? Wait, how do I convert that? How do I convert that? Well, we got to come back here. We've got to look at this equation. We're asked to find the radius. So let's start with that. We know that the radius, if I solve this algebraically, is equal to the arc length divided by theta. Well, technically, the arc length is this stuff here. Right? Because if I were to cut this wheel open and lay it out, 1 revolution would be 0.64 meters. Right? If I were to cut the tire open and just lay it flat. So then we have the arc length divided by theta. Well, 1 revolution is equal to 2 pi, so we could just think of it like this, 0.64 divided by 2 pi. Well, let's do that on our calculator and see what we get. 0.64, whoops, divided by, why isn't that, oh, I gotta put my marker back. Divided by, parentheses, whoops. Not having a lot of luck here with my calculator. Divided by, in parentheses, 2 pi. So I have 0.4 or 0.1 meters roughly. Is that what it says in the back of the book? 0.1 meters it is. So we're saying that the radius is approximately 0.10 meters. Is that right?
Yes.
Any questions? Now, if you're curious about this, how do I justify just putting the 2 pi in here? Remember that I can cancel, another way to write it is you could write it like this, 0.64 meters to 1 revolution times 1 revolution, which is equal to 2 pi radians. And then these cancel, and I just kind of skipped a step. Okay? Any other questions about this one?